We have been reminded about the different subsets of real numbers. Now our goal is to be able to compare and order these real numbers. Now the best way to do that is to make sure the numbers all written in the same format. So when we compare and order numbers, we want to do that by writing them as decimals. So this would be key. Write them as decimals. And if they're both written as decimals, then they're going to be very easy to compare. So the first problem, if you look at example 4, it says the square root of 7, and they want to compare that to 2 and 2/3. The square root of 7, 2 and 2/3. So we're either going to put a less than, greater than, or equal sign in that circle. So let's take the advice that we got at the top of the page. What is the square root of 7? Someone do that on a calculator, please. So 2.64. Let's stop right there. Now, what about 2 and 2/3? Well, if you're good with your fractions, you know that 2/3 is equal to 0.6666, right? So then this would be 2.666. So now all we have to do is compare these. And when you're comparing numbers, basically you want to compare the same decimal place one at a time. So they both have 2 in the ones place. They both have 6 in the 10th place. So we're going to have to look at the 100th place to see where we have our first difference. And 6 is larger than 4, so that means 2.666 is larger. And as Savannah taught us, the alligator wants to eat the bigger number, so it should be a less than sign. The square root of 7 is less than 2 and 2/3. All right, let's do one more of those. I need a volunteer to come and choose a sign, please. Madison, go ahead. That would be great to, you probably want to figure out what they both are. So the square root of 15, what do we have for the square root of 15? Okay, and 3 7/8. What if you just, okay, and then do 7 divided by 8? Okay, so the first 3 digits are both the same, and then put your pen down. Okay, and go ahead and make your choice. Very good. So 3 7/8 is going to be slightly bigger than the square root of 15. So once again, if you don't change these into a decimal, it's actually really hard to compare them. It's kind of like trying to compare things with different units. It's trying to compare something in kilometers to something written in miles. You really need to put them in the same unit if you're going to be able to compare them accurately. All right, let's try another example. Here we have something written as a decimal. Something written as a percentage. How do I change something from a percentage into a decimal, Corbin? You divide by what? Divide by 100, which is the same as moving the decimal point to the left twice. So I go like this, and I'm left with 0.123. And the square root of 0.01 would be what? 0.1. And if it helps you, If you've got empty spaces, you can fill them in because that kind of makes it easier visually to see that this 0.123 is larger. So I would need this greater than sign right there. 0.123 is greater than 0.1. Well, the square root of this is this. Okay? All right, good question. All right, so those were the two examples of comparing numbers. Remember, change them to decimals, and then it's fairly easy to see if it's less than, greater than, or equal to. Now, the last example is a little bit different. We have to try and put these in order, but the strategy is still the same. If I put them all into decimal form, then they're easy to rearrange. So this is obviously just going to be 3. That's not a hard one to figure out. 4.5 can be written as what? 4.5, okay? And 4.21 repeating is still just 4.21. All right, we'll leave it just like that. And then what about the square root of 15? 3.87. So now I need somebody to come up and put these 4 colored numbers in order. I think the book says from least to greatest. Go ahead, Lay. We're putting them in order least to greatest. Least to greatest. All right, so we start off with 3. What would be next? Very good. Cedric, come and do which one is next. All right, do we agree with this? Yes. So 4.5, 4.5 is bigger than 4.2? No, if it's just because a number is repeating doesn't mean it's bigger, okay? So this is still the biggest number, and this one would be right here, okay? And how we do that is we always compare. Their 4s are the same. Now let's go on to the next one. Well, this has a 2, and this is a 5, and the 5 is bigger. So once again, though, the concept is to convert everything to decimal form, and then it's a lot easier to do those comparisons. Go ahead and try the got it's at the bottom of the page 91. Got it D, E, F, and G. D, E, F, and G.